Welcome to Part 1, Knobology, the study of the controls and indicators on the BK Precision 2190B Dual Trace Oscilloscope. Now, as you can see by the figure in front of you, everything's been color-coded. What you'll see in red are the general function controls. The arrows in blue are the vertical controls. The arrows in green indicate the horizontal controls. And finally, the arrows in yellow will indicate the triggering controls. We also have rear controls, which are not shown in this diagram, but are in the rear of the BK Precision 2190B. Hello. In this section, we will cover the general function controls for the BK Precision 2190B. Please refer back to the previous video with the image of the BK2190B with controls and indicators labeled by the colored arrows. As indicated by the arrow labeled 1, this is the on indicator. This lights up when the oscilloscope is on. To the right of that is a power push button. This turns the oscilloscope on and off. Right above that we have the intensity control. This adjusts the brightness of the trace. Slightly to the right of that and below that is the trace rotation control. This adjusts to maintain trace at a horizontal position. Continuing to the right, we have the focus control. The focus control adjusts the trace of the focus. Let's go ahead and move down to this area as indicated by the highlighted beam. Now number 6, right here in the center, is the 20 megahertz, 100 megahertz push button. This is a bandwidth select button. When it is released, it is in the 100 megahertz mode. When it is pressed in, it is in the 20 megahertz mode. To the left of that is the ground terminal. This is the oscilloscope chassis ground and is connected to the 3-wire ground for the AC cord that powers the unit. To the right of that push button is the calibration terminal. This terminal provides a 2-volt peak-to-peak at 1 kilohertz square wave. You can actually use this to check your oscilloscope probe for calibration. And that concludes the general function controls. Hello. In this section, we will cover the vertical function controls for the BK Precision 2190B. Please refer back to the previous video with the image of the BK2190B with controls and indicators labeled by the colored arrows. The 2190B has several features that can be adjusted within the vertical controls. In high sensitivity, you can achieve a 1 millivolt per division and 2 millivolt per division using the pull times 5 control. Otherwise, you get a 5 millivolt per division using the full bandwidth. The calibration is within plus or minus 3% on the 10 calibrated signal ranges from 5 millivolts per division to 5 volts per division as indicated on the controls labeled number 12 for channel 1 and number 16 for channel 2. Another feature is the ability of the scope to add or subtract the waveforms using channel 1 and 2 and displaying it as a single trace. This is indicated on control number 9, which is where we will begin this section. So if you look at where the arrow is pointing, control number 9 is the vertical mode switch. This switch selects the vertical display mode. We have several display modes listed here. Channel 1 displays channel 1 signal by itself. Channel 2 and XY displays channel 2 signal by itself, or if it's used with the XY control trigger, the source switch can be enabled the XY display mode. Vertical mode switch. This is a 4-toggle switch which selects the vertical display mode. There are 4 display modes listed. Channel 1, when selected, displays the channel 1 signal by itself. When the toggle switch is in the channel 2/XY position, it can either display the channel 2 signal, or if the trigger for the XY is selected, up here in the right hand corner, you will be in the XY mode. If the toggle switch is moved to the dual mode, this will display channel 1 and channel 2 signals simultaneously on the screen. The fourth position is add. This takes inputs from channel 1 and channel 2 and they are summed and displayed as a single trace on the screen. If you pull out channel 2's position pull invert control, which is indicated here by the laser beam, then channel 2 can be subtracted from channel 1. Channel 1's AC ground DC switch. This is a 3-position toggle switch. When it's in the AC selector, channel 1 input signal is capacitively coupled. This means that the DC component of the signal is blocked. When the lever is on the ground position, this opens a signal path and grounds input to the vertical amplifier, meaning you have no vertical deflection on the screen. When you're on the DC selection, this means direct coupling of channel 1. Both AC and DC components of the signal are shown on the trace. Moving on to the channel 1X volts per division control knob. This changes the volts per division, the vertical sensitivity of the input and step adjustments. If the variable control, the little knob on top of the volts per division, is in the Cal D position area, then it is set to calibration. The input jack for channel 1, which is related to the control knob for channel 1, is located right here. This is the input for channel 1 signal when the vertical mode is set to channel 1. In the XY setting, channel 1 provides the X-axis input for the XY display, and channel 2 provides the Y-axis input. The channel 1 variable pull ×5 mag control, which is located on top of the volts per division control. This is a variable control. By rotating this knob, we produce vernier adjustments of channel 1. In the fully clockwise position, the vertical attenuator is calibrated, which is called the calibrator region. If you pull the ×5 mag knob out, when you pull this out, it increases the scope's vertical sensitivity by a factor of 5. This can bring the sensitivity to either 2 millivolts per division in the main sweep, or if you are in the XY sweep, it can bring the sensitivity to 1 millivolt per division. Number 14 on your diagram refers to the channel 1 up-down position and the pull chop control, indicated by the laser pointer here. The up-down position, when it's rotated, when this knob is rotated, the trace of channel 1 moves vertically. When you pull this lever out, it's in pull chop mode. This is useful when you are in dual trace. Channel 1 and channel 2 are displayed simultaneously. This is normally used at lower sweep speeds. If it is pushed in, the sweeps are alternately displayed, and that's normally used for higher sweep speeds. Number 15 on your diagram is a channel 2 up-down position pull invert control. Now, when it's rotated, this knob adjusts channel 2 trace the vertical position of channel 2. If you are in the XY mode, rotating this adjusts the vertical position of the XY display. When you pull this lever out, the polarity is reversed, which inverts the waveform, and that's how you can get the subtraction. If you push this knob in and leave it in the in position, the polarity of channel 2 stays normal. The channel 2 volts per division control. This is the same as for the channel 1 volts per division control, but as applied to the channel 2 signal trace. The channel 2 variable pull ×5 mag control. When it's in the variable position and you're rotating the knob, this does the same thing as it does for channel 1's variable knob, except for in this case, when you're in the XY mode, this knob provides Y-axis sensitivity control. When you pull this lever out, it does the same thing for the channel 1 pull ×5 mag control. When the scope is in the XY mode, this knob increases Y sensitivity by a factor of 5. Number 18 on your diagram, and is indicated here by the laser pointer, is the channel 2 input jack. This is the vertical input for channel 2, the Y-axis input when it's in the XY operation. And finally, for the vertical controls, we have the channel 2 AC ground DC switch. the toggle as previously described for channel 1. These operate in the same operation as they did for channel 1. Please refer back to channel 1 AC ground DC toggle switch control. So in this section, we're going to cover the horizontal controls, which are right in this area, and some of the coupling sources that are connected to the horizontal controls, some of the triggering. So let's go ahead and start off with number 20 on your diagram. The number 20 knob here is the main time-based time per division control. So this provides selection of a sweep rate for the main time base. If you have the variable sweep control, which is right up here, set to calibration, then the sweep rate is calibrated. It's done internally, so you don't have to worry about it other than knowing that it happens. All right, so number 21, the next knob we're covering is right here. This is a delay time-based time division control. This provides a step selection of sweep rate for a delayed sweep time base. And then right next to that, number 22, which is right underneath here. I hope you can see this on the laser pointer. So number 22 is the delay time position control. So this sets starting point of a delayed sweep. Clockwise rotation causes a delayed sweep to begin earlier. And then right on top of that, which we mentioned a little earlier, was the variable sweep control. Rotating this knob will cause a vernier adjustment for the sweep rate. When it is clockwise, all the way clockwise, it's in the calibration position, and the sweep is calibrated. Oops, sorry, right there. The mouse moved. Number 24, which is right up here in the top corner, it's in the pulled out position. So this is the left-right position pull times 10 mag control. So when it's in the normal position pushed in, you can move it left to right, and this provides horizontal X position control. When you pull it out, you activate the times 10 magnification. So normal position is pushed in. When pulled out, the sweep is magnified by 10. And the maximum rate is 10 nanoseconds per division. And then the last knob we're going to cover in the horizontal controls is the sweep mode switch right here. So this is a 4-position rotary switch used to select sweep mode. The main mode, so when you select it to the main mode, only the sweep works with the delayed sweep inactive. When you have it on mix, which is the next selector, you get a mix of both the main and delayed sweep on a single trace. The main sweep will be on the left portion of the screen, and the delayed sweep will be on the right portion of the screen. And then you have the delay position. And in the delay position, the delayed sweep is active, but the main is inactive. And you can control the starting point using the delay time position control. And the last control here is the XY, but I'll actually cover that in the triggering controls when we cover that part. The next section we're going to cover are triggering controls, and these are sort of interrelated, so I may go back and forth on some of the descriptions. So if you look at number 26 in your diagram, the hold off control right here, I'm going to go ahead and let the laser pointer off only because it's not steady. So the hold off, the normal position is fully counterclockwise. In this position, the hold off period is minimum. So as you turn it clockwise, the hold off period actually increases. And you have, if you pull it, you go into what's called normal triggering. So when it's pushed in, it's in automatic triggering mode. This is when the oscilloscope is in free run. In normal triggering mode, when the knob is pulled out, a sweep is generated only when an adequate trigger is produced. Let's go ahead and move to the next one, number 27 on your diagram, which is this right here. This is a four-position sweep lever that selects the source of the trigger. So in order for this to work, we have to have our trigger over here on main. You can see that on main. Okay. And so under main, you're going to have channel 1, channel 2, alternate, and external. So channel 1, when this is on main, causes channel 1 input signal to become the trigger regardless of the vertical mode. Also with channel 2, it's selected, this causes channel 2 to be the triggering mode regardless of the vertical mode. When you have here alt, this is used in the dual trace mode, which allows each waveform to be its own trigger source. And then finally, we have the external right down here. When it's on this position, this requires a signal from an external trigger.
And the external trigger is actually located behind the oscilloscope, which you'll see later. Number 28. Number 28 is the trigger coupling switch. It's right next to the source switch. So this again is a 4-position lever switch used to select the following. This is the AC, when it's on AC mode, which is at the very top. This trigger signal is capacitively coupled. That's all that means. When we move to TVB, this is a trigger. It gets a trigger from a television V-sync pulse. And when we have TVH, this gets a trigger from a television H-sync pulse. And when we go down to the very bottom one, which is line, this gets a trigger. The trigger signal is from the line voltage itself. So if you have any idea of how older TVs work, this is an older type of control, which you probably won't be seeing too much in modern equipment, digital equipment. But they have a V-sync and an H-sync, and that's how the image on a screen is synced. You may actually still see it in some medical devices that use CRT devices, that use CRT screens. All right. Now let's go to number 29, which is the trigger level. This is actually the slope control. So trigger level, this determines where the triggering waveform that the trigger will occur. So when it's in the counterclockwise, a counterclockwise rotation means a more negative triggering point, while a clockwise rotation means a more positive triggering point. When it's pulled, you go into negative slope. So it's a push-pull switch. The in position selects a positive slope, and the out position selects a negative slope as a triggering point for the main sweep. And finally, we have the external trigger jack. So this is the connection where the external trigger is connected. I'm sorry if I said earlier that the external trigger was on the back. The external trigger is right up here in the front. A quick look at the back of the oscilloscope, the BK2190B. So what we have here is the power cord receptacle. Hopefully you can see that with the laser pointer. There's also a fuse holder, and it's a line voltage selector. If you actually open this thing up, we can select it to be 120 volts or 220. But right now this is set for 110. All right, we have the channel 2 or Y signal output. So this is a jack that samples channel 2, and it's available through this particular jack right here. We also have the Z-axis input jack. So it's used for intensity modulation of the trace signal. And this concludes the Knobology for the BK2190B oscilloscope. Thank you for watching.